Okay, 7.3 Thermal Inversion. By the end of this lesson, you should be able to describe thermal inversion and its relationship with pollution, and we're going to do this by describing how this thermal or temperature inversion occurs and the relationship between the inversion and pollution. So I want to start by talking to you about a particular case, sort of a landmark case in air pollution, and this was a case in Pennsylvania in 1948 where a thermal inversion trapped sulfuric acid, nitric acid, and fluoride over town. So they were heating up metals here that were releasing toxic gases. After 5 days with this high pressure system keeping the smog down near the ground, it left 22 people dead and then 50 more in the months that followed. And this was considered a big catalyst for what became the Clean Air Act. So their little tagline is that clean air started here. And it was because it was so bad and so many people suffered that it really was eye-opening for people about how important healthy air is. So what is this thermal inversion? So thermal inversion is a natural process. It occurs naturally all the time. It's just when it's combined with the pollution that it becomes a problem. So a thermal inversion is when there's an air pressure system, so any high pressure, pushing down towards the ground and it's trapping cold air. So in a normal system, our sun heats up the earth, the rays come down towards the ground, hit the ground, heat up, and that reflects warm air back up at us. So you can see that there's pollution particles, but they're all relatively evenly spaced around and moving about. But within a thermal inversion, that air pressure traps the cold air underneath a blanket of warm air. And instead of that heat hitting up and then dissipating back out, it's all trapped in a small cycle down here towards the ground. So you may have the same amount of pollution, but it's more concentrated because it's all trapped at a lower level. So here are two pictures that I took. This is in Lewiston, Idaho, where they have a paper manufacturing plant. So the first picture was on a clear day. You can see there's an entire city back here. There's the Snake River um, scenic road. And this is the same spot, relatively similar angle. That's the same road right here. And because of the thermal inversion, you can't even see that there's a city down here. It's completely fogged in with the smog from the paper plant. So this happens in cities and in mountainous areas. So what I just showed you was a mountainous area. This is up in the mountains of, well, not really mountains, but the mountains of Idaho and Washington, which traps that cold air near the ground, causing that air pollution to get worse. We also see this in a place like LA. So these are big issues in urban areas with a lot of vehicles, for example, LA, and they have a mountain chain over here, the San Gabriel Mountains. And when the cool sea breeze comes off the ocean, it should just cycle up and dissipate that pollution. But during times when there's a thermal inversion, it traps all that pollution and it hangs right over the city. So, as with any reaction, when you have more sun, things speed up. So, in hot areas, we see much more of this. And in areas where it's dry, thermal inversion is a bigger issue. And we see in cities where it rains a lot, the rain washes out this air pollution, often in the form of acid deposition, which is also an issue. But what it does is it it gets that pollution out of the air and improves air quality. So in some places they do something called cloud seeding, where they cause it to rain in an effort to improve their air quality. So our goal today was to describe thermal inversion, its relationship with pollution, and as we learned that when it's a natural process, so when the air pressure traps that cold air near the ground, it prevents the air from rising and dispersing pollution. So we get areas of high pollution hanging over places like urban areas with a lot of cars, or in mountainous areas where it's able to trap pollution.